Hello and welcome to today's Experimenters presentation. My name is Simon Barkley and today I'm going to talk to you about shift left and compress. What shift left and compress really concentrates on is delivering the highest possible product or solution at the lowest possible price point. It's not a brand new concept, rather it pulls together good practice in areas like requirements management, risk assessment, defect prevention, test design techniques, prioritization, and couples these with good project and task management, allocating the right people to the right work at the right time. This helps move high cost delivery to low cost delivery channels, resulting in a higher quality solution for a lower price point. Shift left is essentially about moving the activities we normally see at the end, or on the right side if you will, of a project plan, to earlier in the life cycle, or on the left side of the plan, so to speak. These are normally the traditional high-cost test and project activities that are associated with defect identification and remediation, and moving these to lower-cost, earlier lifecycle activities such as static analysis and testing. So how do we achieve this? Through process, people, and tool change. In process, things like utilising the correct review and test design techniques at the correct time in the project, implementing product risk assessments and test prioritization, and by better managing requirements. In people, by redeploying test resources to activities earlier in the project lifecycle. And in tooling, by implementing measurements so you can ascertain where you are at the moment and measure shift left and compress progress and savings. We'll talk a little bit more about that later on. Compress is all about performing these shift left activities in the best way for your organisation, looking at the context of your business organisational goals and testing lifecycle to reduce the number of defects detected. Compress is more the how you do it in order to obtain efficiency and reduce defects occurring and being detected. We achieve this through process change, more defect prevention, less defect detection, better requirements definition and prioritization based on product risk. In people, we do this through the early implementation of training and process support and mentoring. And in tooling, through your ability to measure the effects of earlier and reduced defect detection in a project, and also higher quality solutions in the live environment. So now you've heard what shift left and compress actually means, let's have a look at how this can be measured. The following slides are an example of how you can demonstrate the benefits of this within your organisation. Firstly, we use existing data to establish where we are at the moment. Let's have a look at a defect leakage report. The columns represent the level of testing the defect was detected in, from reviews moving right through component, system, integration, acceptance and production testing into live warranty. The rows represent the origin or root cause of the defect, covering areas from requirements through specification, design, build, environments, testware, implementation and configuration through to users. The shading represents where it's green, good to find defects, amber, bad to find defects, and red, expensive to find defects. You'd hope to find your requirements defects in review and static testing before anything is designed and built or implemented. Equally, you wouldn't expect to find your implementation and configuration defects until later in the life cycle. And of course you don't want to be finding very much at all in your production warranty, where it's the most expensive to fix or unpick your issues. The data you're looking at, with a bit of work on root cause analysis, is quite easy to obtain for most organisations. It's a quick way of helping you understand where you are wasting time and effort and areas for improving. So the next step is understanding from this data what it's actually costing you. Let's apply some base costs to show the real cost of finding and fixing these defects for your organisation. Don't worry too much about this cost being an exact figure. Do your best to ascertain what it's costing to detect and fix at each level with the resources and processes involved at each stage. But if nothing exists in your organisation, whatever you come up with is better than what's there at the moment. We've applied some costs in pounds to the data we had on the previous screen. These costs, as we know, increase per unit at each level as we move throughout the columns. It costs more to detect and fix your defects later in the life cycle than it does earlier in the life cycle. So what would be the effect if we were to adopt some shift left and compress activities? Using the same data, we show that shifting left and compressing, finding a significant proportion of our requirements defects in review and static testing, and propagating less defects later in the life cycle, means that the total number of defects and their distribution, i.e. where they're found, changes. We can show the effect this has on the base costs we established earlier. As you can see, earlier detection and a reduction in the number of defects results in a cost saving of over £170,000. You'll note that reviews and static, as well as production acceptance testing, are actually more expensive stages than previously. This is perfectly normal and is because more requirements defects are found in reviews and statics than in later stages, saving money in all those stages, and more implementation and configuration defects are found in production acceptance rather than production warranty, significantly reducing costs for warranty and contributing to the overall saving. Graphically, we can show this a bit differently and also differentiate out the effect of applying just shift left separately from compress. Here we have a bar chart showing vertically on the y-axis the number and cost of the defects, found across the different stages defined horizontally on the x-axis. These are as per the data from the previous tables and the previous slides through to production warranty. This first slide represents the baseline position with no shift left and compress, first numerically, then plotting out cost for each stage over that. If we apply just shift left activities by themselves, we see the same number of defects detected in a different distribution, shifted left within the life cycle, and the corresponding costs for each stage. This by itself represents a cumulative saving of £103,000, or 19%. Then, by applying both shift left and compress onto the same data, we see further savings, now totaling over £170,000, or 31% of the original spend. So great, I can have my cake and eat it then, can I? Well, as we touched on quickly earlier, you don't often get a free lunch these days, do you? Shifting left will increase the costs at some stages of a project, as we saw. Incorporating static techniques like inspections and code reviews can front-load project costs, but will result in shorter projects using fewer resources overall. These upfront costs are more than offset by the savings later in the life cycle, as we have seen. I hope you've enjoyed today's presentation. If you require any further information on shift left and compress, please contact our office or have a look at the Resource Centre on our website. Thank you for watching and listening to our presentation today. Goodbye.